Okay, then now we can use another example water to explain how covalent bonds are formed in a compound. So for the electron diagram, let me draw again bit by bit, step by step to you. So first of all, so it is about hydrogen and oxygen. So for hydrogen, it is H, and the electronic configuration is 1, and then for O is 2, 6, because the atomic number of it is 8, so it should be 2, 8. Then firstly, we need to work out the formula of the compound. So H and then O. So firstly, you put the number of electrons that is required for each atom to attain octet on top of the element. So for H, 1 electron is needed. And then for oxygen, because the outermost shell already have 6 electrons, so it needs 2 more electrons to become octet. So 2 here, then you cross, then it will be H2O. So after you work out the formula, then draw the electron diagram. So H2O means 1O, and then 2H surround the oxygen. 2H surround the oxygen. So it will be H2O. Then now we can draw the electron inside. So for O, it needs 2 electrons to become octet. So it will share 2 electrons. So if it needs 2 electrons, then it will share 2 electrons in order to become stable. So it shares 2 electrons, so there are 2 spaces here. So it put 1 electron in each overlapping space. And then for H, 1 electron only. It needs 1 electron, so it will share all its electrons, 1 electron here. And then it's not yet done. So for O, originally it has 6 electrons, and then it shared 2 electrons out, so there should be 4 electrons on the O atom. So we draw 4 more electrons here. So now you can check if it is already stable. So how can we check? We check the outermost shell of each atom and see if it is stable enough. So for oxygen, there are 1, 2, 3, 4, 5, 6, 7, 8 electrons. So octet here, 8 electrons. And then for hydrogen, 1, 2. So 2 electrons here, so it is stable then. Okay, so we finished this electron diagram. Okay, some more example is on this page, on this table. So for HCl, for example, it should be 1 electron share because Cl is 2h7. 1 electron is needed to become octet. So it share 1 electron, and hydrogen also share 1 electron. Then after sharing, then for chlorine, you see 1, 2, 3, 4, 5, 6, 7, 8 electrons, so stable. And then for the number of bond pair, let us repeat again. And so bond pair is the pairs that share between the 2 atoms. So 1 bond pair, 1. Okay, and then lone pair all together, 1, 2, 3. For lone pair, they are the electrons that are not shared between the atoms, but stay with the original atom. So lone pair, not forming bonds. And then for CH4, carbon and hydrogen form the compound CH4. For C, it is 2, 4. For C, it is 2, 4, and then H is 1. So C is lacking 4 electrons. So C lacking 4 electrons, put the 4 here. H lacking 1. So it should be CH4 then. So after working out the formula, then you can draw like this, the electron diagram. So when we are teaching ionic bond, some of you ask me, whether carbon can form ionic bond. So because it has 4 electrons, so it is difficult for it to gain 4 electron or lose 4 electron by forming ionic bonds. So for carbon, it mostly form the covalent bond, only sharing of electrons. Seldom can lose 4 electron or gain 4 electron to become ions. So for carbon, it will form covalent bond. Okay, usually it's the case. Okay, and then H2O we've talked about, and NH3 we talked about earlier. And then carbon dioxide, I want to talk about carbon dioxide. So for carbon dioxide, so let me use another page here. So carbon dioxide, firstly, we work out the formula. So carbon is 2, 4, and then oxygen is 2, 6. So for carbon, lacking 4 electrons, and then for oxygen, lacking 2. So 2 more electron is needed. So then we cross, it will become C2O4. So after you work out this, remember we need another step. We need to make it the simplest. Make it the simplest, so it will be CO2. So make it the simplest, CO2. And then we now draw the electron diagram. CO2, 1 carbon, and then 2 oxygen. 1 carbon and 2 oxygen. Okay, 2 oxygen. So now, first of all, we need to put in the electron. So for carbon, it is required to share 4 electrons to become stable. So there are 2 spaces here. So we share 2 spaces. So for 2 spaces, we share 2 each. Then altogether 4. 2 each, and then altogether 4. And then for oxygen, it needs to share 2 electrons to become stable for each of the oxygen. So 2 electrons here, and then this oxygen 2 electrons. Now, we need to also draw the remaining electrons. So for carbon, there are originally 4 electrons, and then they are all share inside the overlapping space. So no more electron on carbon because all 4 electrons have been used. But for oxygen originally 6 electrons in its outermost shell, and then it shared 2 electrons. So there should be 4 more on oxygen atom, 4 more. Then we draw 4 more here. Okay, each of them. And then now we can count the number of electrons to check. So for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So it is stable. For carbon, 1, 2, 3, 4, 5, 6, 7, 8. Okay, or 8 electrons. And then this oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So all these have 8 electrons now, so it is stable. Okay, now for this, I also want to show you how to draw a structural formula. So we write C and then O and then O. So for the bonds between C and O, you can see there are 2 pairs of electrons here. 2 pair of electrons, that means double bonds. And then also here 2 pair of electrons, double bonds. Okay, so it is the structural formula of carbon dioxide. So this is the lone pair, and this lone pair, and these are the bond pair, alright?